Assalamualaikum and salam sejahtera. So we continue with the last reactions for alkyne, which is hydrations. So this reaction is slightly different from the hydrations in alkyne. Okay, so it's still additions of water. Okay, to the triple bond with the presence of sulfuric acid and also mercury sulfate. So the initial products of addition is an enol, which is unstable, and then rearrangements will occur to the products to obtain a carbonyl group, which is C1O group. So the hydrations products will follow the Markovnikov orientations if needed. So for this example, an internal alkyne, okay, so meaning that this carbon has no hydrogens, this one also have no hydrogen, so it is a symmetrical added with H2O with the presence of H2SO4 and HgSO4. So H2SO4 is H and OH, so unsymmetrical. So since one is symmetrical, the other one is unsymmetrical, so Markovnikov rule is not applied here. Okay, so it will produce a less stable enol, so meaning that you can add OH and hydrogens to this carbon or this carbon. Okay, it doesn't matter because we didn't follow the Markovnikov orientations. So this is your less stable enol. Enols means that you have double bond and OH group. So enol. So this structure, okay, is less stable. Okay, so the rearrangements will occur. So the carbon that contain COH bonding will be converted to the C double bond O bonding. Okay, so the other hydrogens, okay, from the OH will be transferred to the next carbon. Okay, so this carbon. So the carbon that originally attached to OH will be converted to C double bond O, while the carbon that attached to the hydrogens from water molecule will get another hydrogens from OH. So this process we call as tautomerizations. So meaning that the enol and the ketone structure is an isomer to each other. Tautomerizations is a type of isomer di mana one locations of double bond and one locations of hydrogens sahaja yang berbeza antara these two isomer. Okay, so let's look at another example. Okay, for this one, we also have internal alkyne. Okay, so meaning that you tak ada Markovnikov rules. So you can attach OH here ataupun you boleh attach OH kat sini. So either location you will get the same products. Okay, so and then remember carbon that have OH bonding, okay, ataupun carbon yang attached to the oxygen, okay, bila dia melalui proses tautomerizations, it will converted daripada COH bonding dia akan jadi C double bond O bonding. Okay, so yang terima hydrogens originally, okay, so dia akan bertukar menjadi CH2. Yang ini yang original dia dah terima, so yang ini adalah H yang diterima daripada structure OH. Okay, being transferred to this one, the double bond akan bertukar jadi C double bond O. Okay, so this one for terminal alkyne, so meaning that, okay, this carbon ada one hydrogens, this carbon has no hydrogens, so unsymmetrical, so you have H2O unsymmetrical, so dekat sini Markovnikov rule is applied. Okay, so OH mesti attach pada carbon yang kurang hydrogen. So hydrogen akan attach pada carbon yang lebih banyak hydrogen. So this carbon ada satu hydrogen, so another hydrogen will attach here. So this one yang kurang hydrogen, so OH akan attach pada dia. So same thing happen, enol is unstable, so dia akan berlaku rearrangements to the keto form. So keto form, carbon yang ada carbon yang ada bonding dengan OH akan turn to C double bond O. So the carbon that originally attached to another hydrogens will get the hydrogen from OH, another hydrogens. So dia akan jadi macam ni lah. Okay. So this is another example, same example. You can read. Okay. So I give you one example. Okay. So let's say your triple bond is located here. Okay, and then reactions with H2O, H2SO4 and Hg SO4. So this one is internal alkyne. So this one has no hydrogen. This carbon also has no hydrogen. So dia adalah symmetrical. H2O adalah H dengan OH. So dia adalah unsymmetrical. If you break down, you akan dapat one part hydrogens. Dia ada part yang akan dapat OH. Okay, so meaning that formations of double bond kekalkan. Okay, sebab kita tambah 1 mol sahaja, so maksudnya from triple bond dia akan jadi double bond. Okay, so next akan ada 2 sigma bond yang baru. So since tak ada Markovnikov rule, so let's say I letak sini hydrogen, the other one I boleh letak dekat situ. Ataupun it also possible structure yang sama, tapi dekat sini saya letak hydrogen, sini saya letak OH. So A ataupun B, dua-duanya correct. Okay, boleh diterima sebab kita tak ada Markovnikov rules. So for A, so ingat enol dia tak stable dan arrow dia memang satu panjang, satu pendek. Maksud dia adalah this one enol state kan. So most of the enol structure will be converted to the keto structure, but only small portions of keto will remain as enol. Okay, sebab tu arrow dia kena satu panjang, satu pendek. So kalau you nak jawab soalan berkaitan dengan hydrations, you nak tahu which one is the keto ataupun enol structure, you look at the arrow positions. Okay, kalau sini, kalau dia buat macam pendek, panjang, maksudnya belah sini adalah enol, sini adalah keto, for example. So yang panjang akan sentiasa pergi ke arah keto, the small one, okay, it is a enol. Okay, so salin balik. So dekat sini ada OH, so meaning that akan bertukar jadi double bond O. So you nak letak hydrogen boleh di sini, kalau tak nak pun tak apa. Okay, for the second one, OH awak berada di situ, so double bond O. Okay, so this is your final structure. So ingat, if you answer this kind of question, make sure jawapan awak mesti last kali pada keto. Sebab keto is your final products. Enol is your intermediate. Okay, kalau intermediate maksudnya bukan final products. Okay, dia akan melalui several process to produce your final product. So if any questions about hydrations of alkyne, make sure your products is the final products which is in the keto form. Okay, so for summary, okay, let's say I have butane. So for the first reactions, if the reactions state with H2 and PT, so meaning that you kena 1 mol sahaja, so daripada triple bond akan jadi double bond. So dia akan tinggal macam ni lah. Kalau you nak letak H boleh, tak nak pun tak apa, sebab this is skeletal structure. Kalau ikut buat condensed ataupun expanded, you kena tambah bilangan hydrogens. So kalau reaction yang sama tapi dia guna linear catalyst, okay, so from triple bond jadi double bond. So linear dalam bentuk cis, so kena tunjuk cis structure. Okay, and then if you have sodium metal in ammonia, okay, same thing, dia mesti dalam bentuk trans, so satu H, satu lagi H di atas. This one walaupun skeletal, you kena tunjuk position, sebab kalau you just leave it macam ni, okay, this structure kita tak tahu cis ataupun trans. Tapi for this one boleh tinggalkan macam ni, sebab H2 dengan PT tidak memberikan sebarang geometrical shape. Okay, so next one you have with Br2 CCl4. So let's say kalau 2 moles maksudnya 4 atom to be added. So from triple bond akan jadi single bond, okay, dengan 4 new sigma bond. And then jangan tinggalkan dalam bentuk macam ni, sebab kalau you tak label terjadi methyl. So make sure tambahkan dengan reagents yang you tambah. Okay, so dia akan jadi Br, Br, Br dan Br. So next, contoh yang lebih kurang sama, okay, which is kita guna 1 mole of Cl2 with CCl4. So same step, you punya reactive site berada di sini. Okay, so because of 1 mole, so from triple bond jadi double bond. So formations of 2 sigma bond yang baru, and then jangan tinggal macam ni juga. So make sure kita tambahkan dengan reagents yang kita gunakan. So sekarang ni you guna Cl2, so tambahkan Cl dengan Cl. Okay, so next one you have, for example, HBr, hydrohalogenations. So same goes to this one. Okay, 1 mole, so maksudnya daripada triple jadi double bond. So ingat HBr is unsymmetrical, so you kena check this one. Okay, no carbon here. Sorry, no hydrogens, not carbon. And then this one, it contain 1 hydrogen. So yang ini pun unsymmetrical. US dengan US kena apply Markovnikov rules. So this one tak perlu, untuk yang ini tak perlu Markovnikov rules sebab dia Cl2, dia adalah S, same goes to this one, similar. Okay, symmetrical juga. Okay, so H kena attach pada lebih banyak hydrogens, so Br akan attach di dalam, H akan attachkan di luar. Okay, so next kalau ada HBr juga, tapi you ada ROO, R ataupun peroxide ataupun H2O2. So in this one kena follow anti-Markovnikov. So 1 more, so meaning that formations of 2 new sigma bond, cuma produk dia akan terbalik. Okay, so for this one, if you ada 2 mole of HBr, so ingat produk mesti dapat germinal. Okay, so this one 2, maksudnya 4 sigma bond yang baru. So kena guna Markovnikov rule, so you akan dapat Br di dalam HBr, sorry, H di luar. Okay, and next one, last but not least, contoh you ada H2O, H2SO4. So ingat final product adalah keto, kalau soalan tak minta intermediates tak perlu bagi. Okay, so formations of double bond pada yang lebih stable, which is macam ni. Kalau dia minta ino intermediate, you kena beri. Okay, so next one yang tertinggal dekat sini, you boleh tambah adalah untuk alkylation. So for example, daripada yang ini nak producing this one. So this is your original structure. Okay, for carbon 1, 2, 3, 4. So you nak tambah 1, 2. So reagent nombor 2 you 1, 2, tarik lagi 1, letak Br. So first reagents adalah Na, NH2. So this is the summary. Okay, and then you are the users and end of the chapter. So thank you.